what is your cognitive architecture of that system?
Hmm.
Okay, so I think the way you characterized it, the cognitive architecture of the system is an LLM, where it gets some data and it gets some rules and it learns on that. But
Who are engineering the systems, what are some of the best practices for them to follow and to basically to create more like human-like reasoning in those agentic systems and models that they're building?
the benchmark has to be easy to evaluate, in the sense that you should be able to just run this as a test script and get a number out, which forces your benchmark to evaluate only the predictive power of the system.
Hi, everybody, and welcome to another episode of the What About AI Agents podcast. Today we have Vinay Chaudhary. He has an impressive background in AI, particularly in NLP, logic programming. He's a principal knowledge system at Knowledge Systems Research LLC. He was an executive director at JP Morgan, visiting lecturer at Stanford University. And I'd let him introduce himself, but I think we should be really excited to hear what he has to say and bring to us in this conversation about the future of AI and the AI agents.
Sure. Thanks, Philippe, for that introduction. I'm a scientist, educator, innovator, and I've had good fortune of leading some technology teams that have been associated with life-changing, uh, life-changing innovations. I like to innovate, but my approach to innovation is through honesty and clarity. I don't like to hype up things as some other people may require for any innovation to be exciting. And yeah, so I think that's a
Yeah,
start.
I mean, and we have a lot of people who are really excited about it, and most of the times they don't understand how these things work. So it's refreshing to have somebody as knowledgeable as yourself. And really, what I like to start with is what makes you excited about the current innovation of the large language models of this agentic systems. What makes you excited about it?
Yeah, I think the exciting thing about the current revolution is that there is a significant and perceptible advance in our ability to make natural language statements to software and get natural language responses back on a wide variety of topics. 10 years ago, if we were to achieve the same behavior from the software, we would have to do a lot of manual engineering. And in spite of that, it would work in only very limited circumstances and only for limited applications. The current large language models, they can solve all sorts of problems in question answering, summarization, and there are some glitches here and there, but by and large, they work quite well, and that's very exciting.
And what are you currently working on at Knowledge Research? Something that you can talk about, obviously. I know some of
Sure.
these things may be.
Yeah, so I am currently supporting an initiative from National Science Foundation to see how we can best complement large language models and deep learning through things like knowledge graphs and more human-like learning and reasoning.
So, how do you do that? How do we create this knowledge graph? So, is this something similar to those graph databases and how you build out those graph databases and leverage them, or how do they work?
Yeah. So the, I'm just trying to recollect my thoughts here. If you if you think of humans and how humans learn, humans don't read trillions of words to learn any topic. Um, if we have to train a large language model, that's what we have to do, right? So there is this belief that in AI we have to be able to impart knowledge to software in a more efficient way, in which we don't have to give trillions of words. We just write certain pieces of knowledge, um, and the software is able to absorb it and apply that knowledge for solving problems. So it seems to us that we need both. I mean, the way of imparting knowledge to software by simply making statements, it has been around for a long time, but it's very time consuming. It is expensive, um, and it's also not as broad as what we see from large language models. But it seems to me that there are some circumstances where simply making the statements should be the way to train a computer. And what is the right combination? What's the best combination? I think that's where the innovation needs to happen. And that's what I'm focusing on currently.
So, do you mean like prompt engineering, or how is this different from, let's say, just asking like a large language model about things?
Yeah. So, I mean, clearly through prompt engineering, you can make statements to the large language model. And in variety of cases, the large language model seems to respond to what you say to those prompts. But I think the very simple example I like to use is, let's say you want to add two numbers. Okay. And
Hmm.
if you add two numbers using large language model, if you ask it to say add 3 plus 2, it'll work very well. But people who are in research, they want to study it systematically. So there is a research paper that was published at the ACL conference last year, where they um, uh, where they tested a large language model on adding two-digit numbers versus seven-digit numbers. So it worked 100% correctly on two-digit numbers, but if you ask it to add seven-digit numbers, the accuracy dropped to like 65%. Right? And and that's kind of silly because if you, as a human, if you learn how to add two numbers, you know how to add two numbers, and it doesn't make a difference whether it's a two-digit number versus seven-digit number. So I think my personal belief is that if you accurately know how to do something, you should be able to simply write it down, and the computer should be able to accurately apply that knowledge and perform that task. But there are certain things where it is not possible to accurately write down how to do a certain thing. For example, how to recognize cat images, right? We cannot accurately write that down, and that's where I think this data-driven LLM approach has an edge, because you really cannot write this down, and there are so many different cases. So it makes a lot of sense to just feed it lots and lots of cat images, and it figures out what cat should look like. Right? But when it comes to adding numbers, we know how to do it. So let's write it down and let's have it do it exactly. Let's have it make no errors.
Well, yeah, we've seen like O1 struggle with mathematics, and then they're saying that O3 is better at it. But we still haven't seen it actually perform any real mathematics or solve anything that hasn't been solved already. So it seems to struggle with logic and reasoning. It sounds like confident when it tries to solve those things, but then it always comes back with the wrong answer anyways. So are you working in that space to help basically improve that output, or?
Yeah, so I think there are two ways of improving the output. One way is you just keep improving your data set. You keep improving your learning model and learning methodology. And I'm not working on that. Okay.
Okay.
The other way of improving it is that for things we know exactly how to do, you simply write them down and have a computer use that written down knowledge in executing on it. That's what I'm working on. Where things that, and I call it more human like learning and reasoning, like the way human would actually do. And I mean, again, I think you could say that, like, if you go back to the image recognition example, let's say, you wanted to recognize cat images. And if you wanted to teach a human how to recognize cat, you will not give it rules of how to recognize cats. You will show the human lots and lots of, or some cats. You probably don't need to show the human as many cats as we have to show a computer. But if you show a small number of examples of cats to a human, they're able to recognize any cat. Right? And I think that's sort of
Hmm.
what I'm trying to figure out as to what combination of small number of examples and explicitly written down rules we can use so that we can improve these existing generation of AI systems.
So really like codify things, because yes, right now what we are basically doing is we are brute forcing those LLMs by feeding them billions of parameters. And it looks like magic, but in reality it's basically a very, 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 very large if statement, and the logic itself is not very complicated logic by itself.
Yeah.
And what you're trying to say is that if we build out this more robust logic and we train LLMs on that, like all systems on that more robust logic, the pattern recognition will become faster with less with less required inputs. Is that kind of what I understand?
Well, so I think that's a good way of characterizing it, uh, and there is still an open question of when you build an AI system, or I should use the word, when you architect an AI system, is what is your cognitive architecture of that system?
Mm.
Okay, so I think the way you characterized it, the cognitive architecture of the system is an LLM, where it gets some data and it gets some rules and it learns on that. But there are many other cognitive architectures in which, I mean, you can imagine a cognitive architecture in which LLM is just a component. There's
Mm.
a piece of code which has a certain steps or certain processing it does, but to do certain steps, it calls an LLM. Okay, so there is that architecture, and I, at a very high level, I like to call that as a architecture which is based on a human mental representation, right? So there is a certain way we as intelligent humans would approach a particular task. Let's build that out into the software, and some steps of that uh, performance of the task we can ask LLM to do. Okay. And so that's a slightly different way of architecting your AI system. I mean, we can't say for sure which one is going to work better, but I certainly prefer the second approach, where LLM is used as a component of a larger AI system.
Yeah, so like in our own code that we do in my company, we leverage LLMs as a way to assist people and not like as a primary agent,
Mhm.
because it tends to hallucinate and make mistakes. So right now people are building purely agentic LLMs, which means LLMs calling LLMs and calling LLMs. But what you're mentioning to me is this human-like cognition. Can we try to dive deeper into what do you mean by human-like cognition, and how can people who are building agents and agentic systems right now leverage that in creating their own kind of better and more efficient and smarter systems?
Yeah. So that's actually a very good question, and I'm glad that you finally bring up the agentic systems here. I mean, the agents have been around in AI research for a long time.
Mm.
And in general, an agentic system is one uh, which is performing like a multi-step processing. It's not just a single step. And in many cases, it can involve um, invoking external programs, right?
Mhm.
And traditionally, in traditional software engineering, we have also built these as like workflow system. So we define some kind of a workflow or a process model of what we want to accomplish, and then different steps in that workflow are implemented using task-specific methods. Agentic systems are essentially doing the same thing, except that in the current generation, there are actually two differences. One is that some of the steps in that workflow execution, they can be sent to an LLM instead of sending to a traditional piece of code. And the other biggest difference is that a few years ago, when we used to build these agentic systems, we needed to understand the API of this external system to which we are sending a request. And now with an LLM, we are able to send an English command to this external system and get an English answer back. So that on one hand, it saves the software engineering, saves the amount of code we have to write, because instead of understanding the API, we are just able to send English and get English back. But it also creates this new problem that with the function call API, we were 100% sure what we are sending and what we are getting back. And with LLM, we are no longer sure that it is actually giving us exactly what we asked for. So then we have to actually build some extra piece of code to figure out that LLM actually did what we exactly asked it to do. Okay. I hope that makes sense.
That's what we have been experiencing with some of the systems that we've been building, where, let's say, you tell it, well, I need you to give me this type of output, and it does it maybe 85, 90% of the time, and sometimes it just says, well, I don't know how to answer that. And you're like, what do you mean? You answered that 100 times before, and now you don't, and because it's unpredictable. Then you have to build these quality systems around those responses and reprompt it and have like multiple retries for reprompts, which drive the cost up. And really, my question is, why can't we have better cognition in LLMs? Why can't we have them be more predictable in a sense of providing these deterministic answers? And how do we make them more deterministic? Like, to your point, the APIs used to be extremely deterministic. You send a message to an API figures it out and sends you a predictable response. Now, you can also have LLM output JSON for you as part of the agentic response. So you have it analyze some video, you have it analyze an image, audio, whatever it is. And then it returns to you the response, but the analysis is not always predictable. So how do we make it more predictable, and how do we create these more predictable cognition patterns for them to follow?
Yeah. So, I mean, I personally believe that there is no magic. I started off by saying that, my approach to innovation is based on honesty and clarity. And I think, to be really honest, we are expecting more from LLMs than what they can actually do. And at the heart of it, they are predictive systems. And the basic property of any prediction is that sometimes it's going to be wrong. And that's the basic property of any prediction. If it was not a predictive system, if it was a completely deterministic system, that's a very different architecture. You just have to engineer the code to be very, very deterministic and very predictive. So personally, I don't mind using a predictive system as a component of my overall system I'm engineering. That's totally fine. But we have to be aware that it's a predictive system. Right? And I think one of the things with the predictive systems is that they give you confidence in their prediction, right? And somehow there has become a culture around LLMs where that confidence information that people have stopped showing in their outputs. And that gives a false impression that, oh, I put this thing in and the system is giving very nice answer, so this answer must be correct. But there is always some confidence level, maybe the system has only 20% confidence in that answer, right? And that doesn't get shown to people. And so I think if we start paying attention to the confidence and we take that confidence into account as we are engineering a larger system, I think we are less likely to make errors.
Yeah, I remember actually when it used to show you this confidence. I recall that, and then now it just answers you, and it's even more apparent when you're doing AI assisted programming, and you have this LLM work with a large code base, and it says, "Oh yeah, I'm gonna help you do this," and it does, and writes all this code, and if you just accept it, you probably have introduced a bunch of security flaws into your systems. You probably broke a bunch of things. And you're gonna spend a bunch of like hours and days fixing it. So for me, I don't like when I do AI programming, I don't trust LLM. So I always say no. I always say just give me a simple answer. I just want to be confident. I'm not confident in its output at all. But when it comes to more, um, let's say, more things like marketing and stuff like that, then it's easier. Then it's easier because it's a lot more fluff that goes in there, I guess.
Right. Yeah, I mean, clearly, for anything creative, it's easier to trust, but at the same time, you want to see what it did, and you want to convince yourself that what it is giving you is up to your standards, right? So, I mean, I think in the creative work, confidence is less important, but in code generation or any kind of like agentic workflow, confidence is important, because if you build a automatic script with multiple steps, one step is feeding to another, and one step turned out to be very low confidence, then you need to know. And maybe you need a different workflow in your piece of code, that, hey, if this previous step had error or very low confidence, I better do something else.
So realistically, what we need to implement are like confidence tests in our code bases that runs this same response against an LM 1,000 times, and you can figure out how many times out of the 1,000 times it fails, and then you can have a statistical probability somewhere in your code that tells you like, well, this has this much of a chance to fail, so it needs to rethink it several times. I do this when I do audio analysis and transcription. I use Whisper,
Okay.
and if I send it an audio file to be analyzed, or at least a chunk of an audio file, sometimes it will transcribe it perfectly. Sometimes it will start to transcribe it and then it will get lazy and says, well, as it was on the previous one. And it's even more apparent in things like video analysis. So if you, for example, drop a video for complex manufacturing process into an LLM and you ask it, well, please describe the process, it will start describing the process fine, and then eventually it gets lazy, and at a certain point it just says, well, it just kind of abstracts it, and that completely ruins the analysis because you're trying to derive what is somebody doing step by step.
Yeah. So again, I think thanks for sharing that experience. I mean, you are very correct that the response is not always predictable. But I would also urge you to be. I shouldn't say urge, but there is this common tendency amongst uh, software engineers to use human-like terms to describe the behavior of LLM. So, what does it mean for LLM to be lazy? I mean, it's a machine. It should do as much hard work as we want it to do. I mean, there is nothing sitting in there which is saying that, oh, I need to get lazy, right? So, but I think folks such as yourself who are engineering the system, they can be um, more rigorous and hard nosed about when you're observing this behavior, and maybe there is some interesting discovery underneath. Every time you see a lazy behavior, maybe there is some new discovery underneath it. If you like more carefully experiment and engineer the solution, you'll come up with something new.
So, how would other people who are engineering the systems, what are some of the best practices for them to follow and to basically to create more like human-like reasoning in those agentic systems and models that they're building?
Yeah. So, I mean, you probably have more experience than I do, but I can give my recommendations from sort of purely academic slash research point of view. Um, I mean, I would say the first and foremost is we should start with some kind of articulation of our mental representation. Like, if I'm going to do a particular task, how would I do it as a human? And that mental representation, I would want to turn that into a piece of code or a set of steps. Okay, so I would want that. So I'll give you an example. Let's say I want to build a program to automatically screen loan applications. Okay. So as a loan application review officer, I have a set of regulations or set of steps that I must follow. And so I would want to first have that regulation or that thought process codified somewhere. And then in that process, I would look at, okay, which step is taking a lot of time, and could I send this to an LLM or some automated script to save me time? Okay. And then I would automate some of the steps, but then for each step, I would pay attention um, to the confidence level. I won't use this as a black box tool that, oh, LLM said this, so this must be true. Look at the confidence and go from there. So just to summarize, I basically have only two recommendations. One is, for any agentic task that you do, make sure that it is implemented in the context of humans' cognitive model, humans' mental representation, which is codified into a model. And in that context, automate some of the steps using LLMs, but always pay attention to the confidence and accuracy with which it is performing that step.
Really interesting. So maybe if we can shift gears a bit and talk about the current research that's happening in the AI space, as I'm sure you're more familiar with what's going on and some of the things that we don't hear about as much. What are some of the interesting developments and things that we can look out for and look into researching to improve our understanding of where these technologies are going and how these things are evolving?
Well, as you know, the news of the week was this model that came out of China,
Interesting.
and there was this big movement in the stock industry, and Nvidia stock fell, and everybody was sort of very worried that, oh, what's going to happen next? What's going to happen next? What should we do? So maybe we can briefly talk about that. I love to hear your perspective on that as well, as to what you thought of it. But but my impression and sense is that the Chinese company, it came up with a um, faster, cheaper way of training the core model, um, and that's great. That's beautiful. And it's open source, so anybody can actually use it. But as you and I have been talking about, the real challenge, or actually getting value and making money out of this technology, is not just the LLM itself. Clearly, LLM is the enabler, but it's the actual end-to-end product that you build around the LLM. And
Mm.
if you evaluate the total cost of building the product, maybe you have just made it easier to build one component, but the ultimate product development, like what does the actual user need, is the output matching user expectations, is the output reliable, how would I actually do the inferencing, how would I actually deploy this, what's going to be the architecture, all of those problems, they still have to be solved. And what this Chinese company did, it was just a small step in the overall thing. And so I think the market reaction is what it is, right? That people reacted, but I think if you take a bigger perspective of a full end-to-end system, this was kind of just a one very um, small component. What was your view? What was your reaction to all that?
Yeah, I mean, I really don't understand what is the hype about, in the sense that it's not like it's a particularly good model, and it's not like its reasoning is particularly good. I would say that it outputs more gibberish than something good, but people are saying it's good at coding. I haven't tested with coding yet. Um, I think from, as you mentioned, from the perspective of building out these massive AI powered systems, LLMs are great, but okay, so you've made certain parts of my system cheaper. Okay, great. So I've reduced my cost. That doesn't, like, LLMs were not that expensive to begin with. Per my understanding, it's unless it's at a massive scale, and then at a massive scale, of course, people are going to see massive returns. But again, this tech has to evolve further. So okay, they were able to replicate what OpenAI did, and they were able to do it with less resources. Great. So if that's true, then OpenAI will be able to train the next bigger model with less resources as well, and then this $500 billion investment that they're making in data centers will essentially train bigger, smarter, more efficient AIs. A lot of it should come from, I feel like AI has gotten very good at text, but it hasn't gotten good at, let's say, analyzing video or like visual feeds or audio feeds at the scale and at the level where it's predictable and good. And a lot of the tech that's going to be evolving, it's going to start going into that, and that's going to require like tremendously more compute than, let's say, text-based LLMs, which is what DeepSeek does. Like, okay, it can Google for you stuff, it can summarize it, great. But as you mentioned, it's a small component. Where, like, why would the entire AI industry tank because one small component got cheaper?
Exactly. So we're on the same page. Um, yeah. So going back to your original question, of what's happening in the research, etc. So I'm doing this workshop at Triple AI. This is the major national AI conference. It's called Workshop on Knowledge Axiomatization, and it has an interesting program. We have a lot of interesting people, AI researchers, coming to this. But one of the sessions is on how do you actually evaluate the intelligence of the system. Uh, we are in a golden age of benchmarks. There are probably as many benchmarks as the number of AI researchers. Um, and the challenge with these benchmarks is that the benchmark has to be easy to evaluate, in the sense that you should be able to just, run this as a test script and get a number out, which forces your benchmark to evaluate only the predictive power of the system. And it biases the system to be only leverage predictive methods. But what if it's not just the prediction you care for, you also care for the actual steps or the process
Mm.
with which you did the prediction? Because lot of human intelligence is in the process. It's not in. I think prediction is important in some cases, and it's useful, but the real intelligence is in the process. Like even for the case of recognizing cat images, um, a human can tell you the mental process, even though they're doing it unconsciously, but they can still tell you what mental process they're going through to eventually recognize a cat. So from my point of view, I don't think we can really advance AI unless we had a good way of measuring the intelligence, which also can
Mm,
check the process and the steps that the system is using to come up with the conclusion. And so we have a whole panel devoted to discussing that. We have somebody coming from educational testing services.
mm.
These are the people who design these GRE and SAT exams. And one question we posed to him is, well, let's say money was not an issue. Let's say you could spend as much money you want in the evaluation. What test would you design to test the human intelligence? And to me, it seems that if we had such tests, which not only looked at the outcome but the process, that would be a great um, step for the AI research.
Yeah, I mean, if you look at the current set of intelligence tests, you look at things like IQ tests, which favor pattern recognition and like basic mathematics. Again, these are not the skills that people really need, and they don't prove intelligence. They just prove that you have learned good pattern recognition, or you've learned the ability to perform mathematics in your head, which are great things. They're like, as you said, they're great processes, and you get a result, and it's good. But it's not intelligent. I don't think like and to your point, the benchmarks that they use to score these models, they are very skewed towards what these models do very well. And it brings to the question, is the current academic evaluation system correct, or does it need to be updated? Because LLM is basically like your calculator for memorizing knowledge. You don't need to memorize vast amounts of knowledge anymore, but you need to know how to apply it and how to create workflows with that knowledge to achieve good results. And if you can create good composite workflows that achieve a certain task in the most efficient way possible, that's a good measure of your intelligence. But if you're just able to provide an output that is correct, looks sensible to a simple question, then what is intelligent about it?
Right. Yeah. So I think you said it beautifully. And in all fairness, we have made progress, right? Even these pattern matching, we couldn't do this pattern matching so well a few years ago, and progress has been made. And but again, the context of this conversation was research, and you are very right that the next level of research is for AI to be able to put these steps together, articulate the prediction process with greater accuracy, and give us more insight into how it is actually doing this.
Yeah, we were just having a conversation with somebody else about how it would be interesting if AI could come up with original thought, identify a problem based on that original thought, and then solve that problem automatically, agentically by itself by creating its own agents and identifying a problem. So let's say AI produces too many hallucinations. It goes, it identifies its own problem, and it builds an interface to fix it. And it automatically kind of fixes itself, or it finds a problem in our society, and it creates a company and fixes it. That's kind of, I think that's but I guess that's not something you can benchmark, is it?
Well, again, I think the people have been clever about things like this. So, like for example, you probably know about this game called Diplomacy.
About what game?
There's a game called Diplomacy. It's a
uh
it's a board game, and
no.
there are multiple characters, and and they have to interact with each other, and they have to make bets, and there are good guys, bad guys,
Mm.
right? So
Mm.
they use that game to kind of benchmark, and there was the system from Facebook in which they stitched together LLMs to play this game of diplomacy, and it did it did better than humans. And so I mean, I think there are ways of doing that kind of thing you're describing, and
Mm.
um, clearly there will be new benchmark tasks. um, as you know, the benchmark, the math benchmark that O1 was demonstrated on, um, which was designed by Francois Chaudhry, um, Arc Reasoning Challenge, ARC. You might have heard
Mm.
of it. So OpenAI has beaten that challenge, and I understand Frank Chaudhry is busy designing a new benchmark, which is expected to come out in March. So it'll be interesting to see, what he comes up with. But I think these are sorts of things that are happening in the field, which are exciting, and I think they are going to move the field forward.
Yeah, I mean, to be honest, not like super I'm not super eloquent in the current like sets of benchmarks that they actually run them on, and maybe some of our listeners aren't either. So maybe you can explain to us how do these different AI benchmarks actually work, and what what does the AI have to do in order to get a high score in that benchmark, and how is it structured?
Well, the uh, Arc Reasoning Challenge benchmark, um, it was more of like a visual analogy benchmark. So you would be shown a set of squares and two pair of squares, and then from those squares there are uh, you have to infer some abstract reasoning rules. So abstract reasoning rule could be, well, to go from this square to this square, you take the three central squares and you flip them. I mean, I'm just making up one example. And so he had thousands of examples like this, and he had some examples which were um, held back in the sense that they were not shown to the world, so that OpenAI could not train on them. Uh, so people thought that this was very difficult, and up to about a year ago, um, the AI systems were getting a score of about 20%. And
Mm.
this is what O1 OpenAI's O1 system got more than 80%, and that's what sort of is forcing Francois Chaudhry to think about, oh, okay, what should be my next benchmark? That by itself is a whole topic of a full episode. I mean, I've just scratched the surface of what these benchmarks are, but I will share with you two links. One of
Mm.
them is to this benchmark I just talked about, and one of them is to a survey of benchmarks, which very nicely gives examples of the various AI tasks and what AI systems have to
Mm.
do, which I think would be of interest to you as well as to your listeners.
Yeah, that would be interesting, and maybe we can schedule another episode, maybe in a couple of weeks. I don't know when you have time, but where we can just dedicate it towards understanding what are all these benchmarks and how are why are they important? Because I know like they do like abstract reasoning, and but sometimes we need to figure out what are they testing them on, because in some cases these benchmarks may mean a lot, but while in other cases they don't really, as you alluded to, they don't really prove intelligence. They just prove generative capabilities, which are good, but not really intelligent.
Right. Yeah, I think that would be great. I would be happy to schedule something in March. That
Yeah.
is after the workshop, because that way, I can also share with you what we learned at the workshop and what happened at the workshop. And yeah, So yeah, I'd love to do that in March, and we can go from there.
Perfect. Well, this was Vinay Chaudhary. He really has brought in some very interesting topics, and you brought up some good points about how we are designing the systems and how this is evolving. And on the research side, because I always talk about to people that are like writing these agents or people who are deploying them or who are fantasizing about them from like a civilian perspective, but from the research perspective and how they actually get benchmarked and how they work. We don't have too many scientists that join, so it was really really good to have you and to hear your opinions. It's really interesting, and really excited to have you back in March to talk about benchmarks and how
Perfect.
they
Thanks,
work.
Felipe. And I will share with you two references that I just mentioned. And looking forward to talk to you more about benchmarks.
Thank you so much, Vinay.
Okay.